Hello guys, and welcome to the GCE Math Panel Online. In this particular presentation, we have June 2021 paper 1 770. Please don't forget to subscribe to this channel, to share this video with friends, to leave your comments and likes, and to follow us on Facebook and on Twitter. Equally, you can have past papers and other materials for GCE on our blog www.gcemathpanel.blogspot.com or gcemathpanel.com. Please don't also forget to go to that blog and join our online preparation that runs every August to May in preparations for the GCE for the different subjects. Welcome once more. Let's begin with this paper. So the first thing I would like to reiterate here is that when you get your question paper, don't forget to fill in the correct information that is required. And as I've mentioned before, please get to our blog and join us for this serious full-time preparation online for the GCE. This is what we do every year, and don't be an exception. Share this information with all of your friends, that together we may put hands on deck and make our world a world of mathematics, the citadel of maths. We begin with question 1. The vector equation of a line passing through the points 1, 3, 4 and parallel to the vector I minus j plus 2k is... The vector equation is given by r equals a position vector plus a scalar times the direction vector, which can be written as this. Here we have the position vector, which is this 1, 3, 4, and it is parallel to this direction vector I minus j plus 2k. Even if they change this direction vector to or multiply it by negative 1, we will have minus I plus j minus 2k's. We will still have the same thing for this b here. So in this case, our result will be as follows, and we have the key to be C. The second question reads, a binary relation R is defined on the set of natural numbers by m relates to n implies m plus n is odd. R is... The relation is not reflexive since any odd natural number plus another odd natural number will give us an even number. Equally, if you take any two natural numbers, if they are both odd, the result will be even, and if they are both even, the result will be even. So it will only be odd if one is odd and the other is even. So this relation is not reflexive, because if we have, for example, 1 relates to itself would be 1 plus 1, which is equal to 2, and 2 is not an odd number. So the key here is the relation is only symmetric. And why is it symmetric? It is symmetric because addition is commutative. For example, 2 plus 3 is 5 and 5 plus 3 is 2. So it is symmetric. Question 3. Given that the roots of this equation are m and n, and also given that 3m is equal to 4n, find the value of the constant k. In this particular question, we are supposed to use the sum product property of quadratic equations. This means, in this case, we have x squared minus sum plus product equals 0. So minus sum, a minus sum will give us minus 14. So minus sum will be equal to minus 14. And since we have been told that 3m is equal to 4n, it means that m is equal to 4 on 3n. So our sum will now be 4 on 3n plus n, which is equal to 14. From here we can solve for n, and the value of n will be equal to 6. And our k, since it's the product, is mn. We have m to be equal to 8 by substitution, and our k, which is equal to mn, will give us 48. Our key here is D. Please, if you are watching this video, make sure you watch it till the end, because there are some new concepts that have been introduced this year which you should not let them pass by. These concepts are equally very important in paper 2 and paper 3, as you will see in the paper 2 and paper 3 that will be uploaded shortly. Question 4. The gradient of the tangent to the curve with parametric equations that and that, where t is a parameter at the point where t equals 1 is. So since we are looking for the gradient of the tangent and we have this equation in parametric form, candidates first of all need to look for dy dx and substitute t equals 1. So at dy dx here, or let's start with dy dt first, since it's in parametric form, is equal to 3. And at t equals 1, we will still have the value to be equal to 3. Equally, dy now, or dx dt rather, dx dt is equal to minus 2 on t squared. And at t equals 1, the value is equal to this minus 2 here. Therefore, our dy dx, which is dy dt times dt on the x, will be equal to minus 3 on 2. Normally, you can do the equation completely. You look for dy dx completely before you substitute this value, but you can still have the result like this. The result will be the same. Question 5. The range of values of x for which absolute value of x is really greater than 2 minus absolute value of x is. We have so many lessons on a block on this particular absolute value equations for advanced level. These are the first lessons of the first chapter. With an equation like this, you see that these are like terms. So we can bring these like terms together. And when we bring these like terms together, we will have absolute value of x times 2 is greater than 2. And when you divide both sides, we have absolute value of x to be greater than 2. And finally, using the rules, if you have issues on this lesson, go to the block. When we break this down, this is the results that we obtain. So our key here is A. Question 6. When a polynomial function f of x is divided by x minus 1, the quotient is 2x squared plus x minus 2, and the remainder is 3. The polynomial f of x equals. We have to use the relation of polynomials defined as dividend divided by divisor equals quotient plus remainder. And this will imply we have f of x, which is the dividend, this f of x, divided by this divisor, which is x minus 1, should be equal to this quotient. The quotient here is 2x squared plus x minus 2, and we have been told that the remainder is 3. But we have to be very careful in simplifying this operation. We have to do it as follows. F of x will now be equal to this quotient times this dividend, or this divisor rather, now plus the remainder. Look at where you're putting plus the remainder. So this is how it should be done. Be very careful not to make a mistake and do something else. When we expand and simplify, these are the results that we will obtain. And our key here is B. Question 7. The value of theta for which that expression is minimum is. Here, the function is minimum when the denominator is maximum. So when this denominator is maximum, this function will be minimum. And for this denominator to be maximum, there is a condition. For the denominator to be maximum, the sine of this angle must be equal to 90, because you know that sine 90 is equal to 1, and that's when you have the maximum value of sine. So it means therefore that this value inside this bracket should be equal to 90. So we say theta minus pi on 3 should be equal to 90, and then we solve for theta. At this point, our theta will be equal to pi on 2 minus, or rather plus, pi on 3, and this will give us 5 pi on 6. So theta should be equal to 5 pi on 6 for us to have the minimum value here. Our key here is A. The next question. The set of values of x for which this polynomial is greater than 0 is. We first of all start by looking for the boundary solutions. Boundary solutions occur when we equate each of these brackets to 0, we will have x equals 1, x equals 3, and x equals a half. We write it in ascending order like this. Then we can use the number line tool or a table of values to work it out. So here, these are the values, and we know that since this is an inequality, the values are a range. So we have this range for x less than a half, the range between minus a half and 1, between 1 and 3, and above 3. So you have to test. We take values and test in each of this range. For example, let's just take any number less than minus a half. We can take minus 1, right? When we take minus 1 and fit here, minus 1 is negative. That will give us negative. As you can see, this first bracket is negative. Minus 1 minus 3 also give us a negative number. And here 2 times minus 1 plus 1 is still negative. So it's negative times negative times negative. And what is the product? The product will be equal to negative. So you can already see that this region below minus a half does not satisfy, because the product of all of these should be greater than 0. And anything that is negative is not greater than 0. Now let us test in this region between minus a half and 1. We can easily use 0 because it will be easier and faster. So we fit zeros all through here. We have this one will be negative, this will be negative, and this one will be positive. So we'll have this result negative, negative, positive. And when we multiply all of that, we'll have a positive value. This one satisfies because it's greater than 0. The number must be greater than 0. And then we take a number between 1 and 3. We can take 2, for example. This will be positive, this will be negative, and this will be positive. So we will have positive, negative, positive, and the product is negative. So this region is negative. And above 3, all the values will be positive. Therefore means that our solution is this. From negative we have to 1 and above 3. So our key is D. Question 9. Given that y equals x to the power sine x where x is greater than 0, find dy dx. With this type of questions, dear candidates, we start by taking ln on both sides first of all. So we take ln y should be equal to, when you simplify this ln on the right hand side, you have ln x to the power sine x, but you can bring it in front from the third law of logarithms or from further powers. We can bring this in front. Yes, so this will give us sine x ln x. We now differentiate both sides. When you differentiate ln y, you have 1 over y dy dx, right? And that should be equal to, for the right hand side now, we will have when you differentiate ln x, you have 1 over x, you hold sine x constant. You now differentiate sine x, you have cos x, and you hold ln x constant. So this is what we have. We now solve for dy dx, or make it the subject of the formula, and our dy dx will be equal to sine x over x plus cos x ln x, all of that in brackets, times y. So this is the result that we have, and this gives us the key to be D. The key to be D. So we are talking a bit not much fast, because most candidates out there complain that our videos are fast, though you can equally control the speed from your device, but we are taking it at a moderate pace. Question 10. Let A be equal to that matrix and B be equal to that matrix. The order of the matrix product AB is, in this question you don't need to look for the matrix product AB. So the order of the products that will be obtained AB is given by the order of, or let me say, the number of rows of matrix A by the number of columns of matrix B. So just by looking at these two matrices, the order of the product that will be obtained is, we start with the A, right? It has 2 rows, and this one has 2 columns. So the order of the product that will be obtained is a 2 by 2 matrix. So this is what we have. For A, we have 2 by 3, that's the order. And for B, the order is 3 by 2. So the order of the matrix of the product that we obtain, AB, will be this 2 by 2 matrix. And these numbers here tells us whether they're compatible or not. If the value that is here is not equal to the value that is here, then this matrix product is not possible. So they can ask what is the condition for this matrix product to be possible. We say that the number of columns for matrix A should be equal to the number of rows for matrix B. If they are not equal, it is incompatible. So our order here is 2 by 2. Our key is D. Question 11. The number of arrangements of the letters of the word manner in which A's are together is. In this case, we consider the two A's as one, so we will have just 4 letters, of which 2 are identical, and this gives us, so since the A's must always be together, we can consider that the 2A is equal to 1A. So our word will now look like this: man, without the A at the end. So we consider this 1A here is equal to 2A's, but since they must always be together, they function just as one member. So this gives us 4 factorial over 2 factorial, and that is equal to 12. So we have 12 arrangements. The function f of x is defined as that with 2 intervals. Given that f of x equals f of x plus 4k, where k is an element of the set of integers, find f of 15. So to find f of 15, first of all, consider that the period of this function is 4. You can see from here from 0 to 2 and from 2 to 4. So the period is from 0 to 4. The period is 4. And since the 15 has been given here is positive, we can just divide this by the period. 15 divided by 4 gives us 3. We are interested in the remainder. So we have 15 divided by 4, and that gives us 3 remainder 3. We are interested in this 3. So this f of whatever you're looking for here is f of 3. And we see that this 3 lies in which interval? Is in the first interval or the second? 3 lies between 2 to 4. So we are going to use by this second part of this function to look for f of 3, because the 3 lies in this interval. And this will give us the value of 3 times 3, which is equal to 9. Note, if we were looking for f of something like -15, we will not use the same procedure. We will have to add multiples of this period of this function, that is 4, until the number becomes positive, like this. 15 plus 16 is plus 1, and we can now look for plus 1. And when we look for plus 1, this is what we will have. You give us a value of 3. So be careful with this. Our key here is 9. It's D rather, which is having a value of 9. Question number 13. We have the statements P and Q. John is eating. Q, John is playing. The proposition negation of Q implies P is. So the negation Q of Q is John is not playing. Or here we can use if or whenever, since we have to merge or combine these two statements to form a compound statement. So this is how we do it. So the negation of Q is John is not playing. So we say if John is not playing, this implication here is this then is replaced by then. We say then what happens? He is, this is P now, he is eating. If John is not playing, John is eating. There's no need to write John 2 times, as we know. So if John is not playing, then he is eating. 14. Values of y for which the values of x are shown in the table below. Using the trapezium rule, find the integral from 0 to 4 of y dx. For the trap rule, we need to understand that the number of strips is equals to number of ordinates minus 1. Ordinates means how many x values. Ordinates we have 1, 2, 3, 4, 5. So we have 5 ordinates minus 1 will give us the number of strips or of stripes. So, and we know that our h for the trapezium rule is b minus a on n. This b and a is the lower bound, b is the upper bound, while n is number of ordinates minus 1. So this will give us n to be number of ordinates, but that is 5 minus 1. And we have our b minus a to be 4 minus 0. When we simplify, we have h to be equal to 1. Now applying the trapezium rule, we have that integral, and we fit in the values, which is h over 2 into first value of y plus last value of y plus 2 times the sum of the rest of the values of y. So this is giving us 1 over 2 into 4 plus 4 plus 2 times 6 plus 7 plus 5. This will give us 6 plus 7 is 13, plus 5 is 18. 18 times 2 is 36, plus 4, 40, plus 4, 44, divided by 2 is 22. So our key here is B. Question 15. The variables x and y are related by the law that. Reducing this law to linear form gives. So we just take log on both sides with this type of law. We take log on both sides. This one you see I've seen mostly in sketching curves and various these relationships of equations or linear relationships. So when we take log on the left hand side, we have log y to be equal to. For the right hand side, when we take log, this is log of a product. So it's log a squared plus log b to the power x. And then we can simplify. So we now have 2 log a plus x log b. And this corresponds to which of these? This corresponds to A. So our key here is A. Then question number 16, the general solution of the differential equation that is. We first of all start by separating the variables and integrating gives. So we separate the variables, we have dy on y is equal to sine x over cos x dx. The sine x over cos x is tan x. So we introduce the integration on both sides, dx. So on the left hand side, the derivative of y on y is ln y. The integral of tan x is ln sec x, the absolute value of sec x plus k. So our key here is C. The sum Sn of the first n terms of a sequence is given by Sn equals n into 1 plus 2n, all of that times ln 2. The fifth term of this sequence is, so since they've given us the sequence in terms of sum, the fifth term should be equal to the sum of the first 5 terms minus the sum of the first 4 terms. So putting in these values to give us S5 to be equal to 5 into 1 plus 2 times 5 is 10. So 1 plus 10 ln 2, and simplifying gives us 55 ln 2. Equally, S4 will be equal to 4 into 1 plus 2 times 4, that is 8 ln 2. And this is equal to 36 ln 2. So our T5, that's the fifth term, T5 will be equal to S5 minus S4. And this will give us a value of 19 ln 2. B. Given that the equation 4x squared minus 3kx plus 1 equals 0 has equal roots and k is positive, the value of the constant k is equal to, or k is strictly greater than 0. The roots are equal if the discriminant equals 0. This is the condition now from quadratic theory. So we have discriminant which is equal to b squared minus 4ac should be equal to 0, and we get the discriminant here. This will give us minus 3 squared, minus 3k squared plus minus 4 times a, which is 4, times c, which is 1. That should be equal to 0. When we simplify this, we have 9k squared minus 16 to be equal to 0. And from here, our k is equal to the positive square root of 16 on 9. Why? Because we have been told that k is strictly greater than 0. So you are not considering the negative roots of this. So our key here is B. (19) The equation of the circle with center at the point 1, 3 and passing through the point 2, 7 is. So if this equation passes through this point 2, 7, then normally knowing that the equation of the circle is given by x minus a squared plus y minus b squared equals r squared, where r is the radius and ab are the coordinates of the center. So our ab here is 1 and 3, and our r will be 2 minus 1 squared plus 7 minus 3 squared, the square root of all of that. So our r is equal to root 17, and when we square this, we will have 17. So we have x minus 1 squared plus y minus 3 squared is equal to 17. We have removed all the roots. A key here is B. Question 20. To express this in partial fractions, we should look for the values of P and Q respectively. So in partial fractions, we have 2x minus 3 over x minus 3x minus 2 to be identical to that which has already been given. So from here, we multiply all through by the denominator, and we have 2x minus 3 to be equal to P into x minus 2 plus Q into x minus 3. Now, if x is equal to 2, we'll have 2 minus 3, which is minus 1, to be equal to this one will be 0. And we have 2 minus 3, which is equal to minus 1. So we'll have, okay, here we have 4 minus 3, which is 1, and here minus Q. So finally, our Q will be equal to minus 1. Now, when x is equal to 3, this term will cancel out, disappear. And we'll have 2 times 3, 6 minus 3, which is 3, and our P will be equal to 3. So P and Q are respectively 3 and minus 1. The range of values of x for which that expression is greater than 0 strictly is. So the boundary solutions here are, first of all, x equals 0 and x equals minus 3 from numerator and denominator. And we can solve by testing. So we have minus 3 and we have 0. So we test which points. Below 3, take any number below 3. And let's test. We start, we take any number like minus 4. Numerator will be negative, denominator will be negative. So this value will be positive. Now between minus 3 and 0, we can take 1 now. When we take 1, we will have, minus 1. Minus 1 plus 3 will be positive, and denominator will be negative. So this value in between will be negative. And above 0, you can take 1, for example, is going to be positive. So they want us to give the range of values for which this is going to be positive. So is that the range is below minus 3 and above 0. 22. The equation of a circle with endpoints 4, minus 2 and 3, 2 of its diameter is. So with the equation of this type of circle, we just have x minus x1. This is x1, y1, x2, y2. So the equation of that circle is x minus x1 times x minus x2 plus y minus y1 times y minus y2 should be equal to 0. So our key here is equal to A. 23, we have this integral from minus 1 to 2. The first thing to do this integral, you consider the numerator is having the same degree as the denominator. So we first of all use long division and break it down as follows. X plus 3 on x plus 2 is equal to 1 when we divide using long division plus 1 over x plus 2. We can now apply the integration on both sides, and this is what we will have. When we integrate, we will have x for this plus, when you differentiate this one, you have 1 plus ln x plus 2. I'm not adding the constants here because you have definite integration. We now apply the limits, and the limits are from minus 1 to 2. So this will give us, for 2, you have 2 plus ln 2 plus 2, ln 4 minus 1 now plus ln minus 1 plus 2, ln 1. Ln 1 is 0. So this will just give us 3 plus ln 4. Our key here is D. 24. The expansion of the function that is valid for. So this expansion is valid if this absolute value of this 3x is less than 1 and the absolute value of this x here is less than 1. So we have two values, but you see that for absolute value of x to be less than 1, we have from minus 1 to plus 1. When we take the intersection of the two, we have just this one like this. Just this minus 1/3 to plus 1/3. So we take this one because we need the intersection and not the union. It has to be valid for both, and this is the only intersection that occurs. Okay, question 25. The Cartesian equation of the curve whose parametric equations are x minus 1 equals sec theta and y plus 1 equals tan theta is. When we look at sec theta and tan theta, we can look for a relation that brings them together. We know that sec squared theta is equal to 1 plus tan squared theta, right? So let us use this identity of sec squared theta is equal to 1 plus tan squared theta. So sec squared theta will be x plus 1 squared. Then our tan squared theta will be equal to y plus 1 squared. So we have sec squared theta plus is equal to 1 plus tan squared theta. We can now bring these like terms together after simplifying. When we simplify, this is what you obtain, and finally we obtain b as the result. So the most important thing is to know what to do. I've just gone fast and forward with this one. So our key here is B. Question 26. Please don't forget to subscribe to this channel, and you can go back to our blog www.gcemathspanel.blogspot.com. There you have the past papers for all the different years. You have information about concours. You have papers for all the other subjects. You have a lot of information that I cannot be disclosing here because there is just so much. Equally, it's very important that as you're preparing for GCE this year, go to our website gcemathspanel.com and join the online preparations. If you have A level or O level, technical or ATC, any of them, you choose your level and you join the other hundreds of students who are preparing for the GCE. Early preparation prevents poor performance. Don't forget. Alright, we take the next question, number 26. If the matrix that is not invertible or it is singular, and then the value of k is. A matrix is not invertible means its determinant is equal to 0, or the matrix has no inverse, because invertible means has an inverse, not invertible means does not have an inverse, and this only happens when the determinant is equal to 0. So we will solve, we look for the determinant here and equate to 0. You can use other methods with determinants. There are many ways to get the determinant of this matrix, right? And then we can solve for k from there. So from this point, our k will be equal to 3. Use any of the methods. You can even use a Saros method and all the other methods that you already know to get this the determinant. So our k here is equal to 3. Question 27. You have this integral. Here we need to use the substitution u equals x squared plus 3. You can see that when you differentiate this one, you have this 2x dx now. So let's use the substitution u is equal to 2x or x squared plus 3. So our du will be equal to 2x dx. And when we bring this inside here, we're going to replace this 2x and this dx by du. While we replace x squared plus 3 by u. And then to the power 3 on 2. So this will give us u to the power 3 on 2 du, and then we integrate. This will be equal to u to the power 5 on 2, all that over 5 on 2, and that will be the same as multiplying this thing by 2 on 5, then plus the constant of integration. We can now replace the u by its value, which is x squared plus 3. And note that when we do this replacement, now this k will now change from this k to k prime. But in this question, we can just leave it like this. It does not matter. Let me say I wrote the k prime here and I've replaced it now with k. So our key here is going to be C. (28) A first approximation to the root of the equation e to the power x plus 2x minus 1 equals 0 is x equals 1. Using the Newton-Raphson method, a second approximation to the root of the equation is. Please don't forget to watch the paper 2 and paper 3 of this paper online, and don't forget to subscribe and share these videos and leave your comments. So the second approximation from this is the first root. It is always denoted x0. So we need a second approximation, and the second approximation is denoted x1, which is equal to x0 minus f of x0 on f prime of x0. So let's look for f of x0 is 1 now, so f of 1 here will give us e plus 1, and our f prime, when we differentiate this, we have e to the power x plus 2, and e to the power f prime of 1 will be e, just e plus 2. When we replace these values here, we'll have 1, this 1, minus f of x0, all that over f prime of x0. So our key here is A. Question 29. The equation x cubed plus 3x minus 5 equals 0 has a root lying in the open interval. First of all, note that open intervals are written like this, or you can use these brackets in which the brackets are not facing each other. So f of x has a root in the interval AB if f of A times f of B is negative or is less than 0. So we are going to test each of these. We test the first one. We will have f of 2 times f of 3, and this will be equal to, we put these values here now, f of 2 is going to be positive, as you can see. F of 3 will also give us a positive number, so it's positive. Then f of 0 times f of 1 is positive 2. F of 1 times f of 2 will give us a positive number times a negative number, and f of minus 1 times f of 0 gives us a positive number. So the only one here that gives us negative is this third one, which therefore means that the curve crosses the x-axis only on this along this interval. So therefore means that the root lies in this interval. So our key here is C. 30. Given that the absolute value of z minus 3 equals 2 times the absolute value of z plus 3, where z equals that, the locus described by z is... The first thing I'd like us to notice here is that if you look at the coefficient of z here, it is 1, but the coefficient of z here is 2. With these absolute values, you just know that this describes a circle. If they were the same, it would be a line, because the x and y values may cancel out. This will surely give us a line. But now that the coefficients of this z are not the same, you hear the coefficient of z here is 1, because you can send these 2 inside. So this describes a circle. You don't need to solve for this one, but I'll still show you why it is a circle. So we replace this x, this z by x plus y, iy, and simplify. This gives us the first one, x plus iy minus 3 equals 2 into x plus iy plus 3. And when you get these absolute values, this will give us x minus 3 squared plus y squared equals 2 into x plus 3 squared plus y squared. And when we simplify and bring like terms together, we will end up in an equation of this form. And you can start, this is the equation of a circle. So our key here is A. A to the x ln 5 is equal to, this can be simplified as e to the power x ln 5 is equal to e ln 5 to the power x. This is one of the laws of logarithms that you know. And we know that since the base here, this ln means the base is e, and you have e, when this base is raised to the log of that same base, the result is equal to just the function that is there. So our value here will be just 5 to the power x. These questions come every year now. GCE board. Asia. Then question 32, the approximate change in the value of ln x if x changes from 10 to 10.1 is, here you just have to look for this change, and this change is estimated as ln 10.1 minus ln 10. Just punch in a calculator, it gives the answer directly, no stress. And this gives us this. Let us make the values to be as many as this, because we have 1, 2, 3, 4 decimal places, so we can take up to 5, so that if we approximate, we'll see what the answer gives us. So when you approximate this one, instead the only value we can have is this c value. So that gives us 0.0, this d value 0.01. 0.01. 33. The vectors that and that are perpendicular if the scalar q is equal to. So two vectors are perpendicular if their dot product is equal to 0. So we have to look for the dot products here. we will have 2 minus q minus 1 dot minus 3 minus 2 plus q should be equal to 0. This will give us 2 times minus 3, which is minus 6, minus q times minus 2, which is plus 2q, minus 1 times q, which is minus q, equals 0. And solving for q here, q gives us a value of 6. Our key here is C. 34. The vector perpendicular to the plane that is given by. Now, to get this vector that is perpendicular to this plane, it is given by the coefficients of x, y, and z. So the coefficients of x, y, you have 3 minus 5, 1. 3 minus 5, 1. So you can see that the key is already B, right? Let's recall that for us to have this, the vector equation of a plane, we have r dot the normal to the plane equals OA dot the normal. And this can be written as AX, since this R is x, y, z. So you have AX plus BY plus CZ equals D. This D is when you bring this A dot N to the left hand side, or when we leave it like this on the right hand side, and our D in this case here should be minus 7. Alright, so that is what we have. So the normal to this plane is this. From this equation you have 3i's minus 5j's plus k. You can see it directly. Alright, the last question for this first part before we move to the remaining 15 questions on statistics. We have A is equal to tan inverse of 5 plus tan inverse of minus 3. Then tan A is equal to, with this question we take tan on both sides. We take the tan on both sides and we lose the simplification for tan to simplify. So we have taken tan A on both sides, you have tan A to be equal to, these are two angles, right? This is like alpha plus beta. So it's equal to the tan of the right hand side. So when you have tan A plus B, how do you simplify it? You simplify it as tan A plus tan B, all that over 1 minus tan A tan B. So that's what we are going to do here. This will be equal to tan inverse of 5 plus tan inverse of minus 3. Then we are going to divide that value by 1 minus tan inverse of 5 times tan inverse of minus 3. Then we now simplify what we have. When we simplify what we have, we will have this tan inverse of 5 here will just be 5. Tan inverse of minus 3 will just be minus 3. All this over 1 minus 5 times minus 3. So this will give us 2 over 16, which is equal to 1 over 8. Yes, they gave this type of questions equally some years back. And they take most of these questions and repeat them and give the same thing. They just change the values. So you just have to be wise and solve some from recognition. Alright, you can equally look at other past questions and answers that we have like this, like 2019 and 2020 A-level. And you can equally get them from our website www.gcemathspanel.blogspot.com or gcemathspanel.com. Question number 36. Now statistics. The probability distribution of a discrete random variable x is given below. Find the expectation of 2x minus 3. So the expectation in general is given by, if you have something like 2x minus 3, the expectation is given by expectation of ax plus b is equal to expectation of x times a plus expectation of b, or a times expectation of x plus b. And using this one here, we just need to get the expectation of x, which is sum of xi times probability of xi. So we have 2 times 0.5 plus 3 times 0.3 plus 4 times 0.2, and this gives us a value of 2.7. So our expectation of 2x minus 3 will be equal to 2 times this 2.7 minus 3, and this will give us a value of 2.4. 37. The cumulative distribution function capital F of x of a discrete random variable x is given below. So with this, we have probability of x equals 1 is 2. Probability of x equals 2 is actually here 0.12. So they add them. The probability of this one to the probability of this give us 0.32. They add the probability of when x equals 3 to have this until the last value here should be 1. So how do we get the probability of x equals 4? Since this is a cumulative distribution, the probability of x equals 4 should be given by probability of x equals 4 should be equal to, since this is the sum from 1 to 4, 0.9, minus the sum from 0 to, or from 1 to 3. So is the accumulation from x equals 1 to x equals 4 minus the accumulation from x equals 1 to x equals 3. And this gives us 0.9 minus 0.67, which is equal to 0.23. I would like to thank all the candidates out there and the teachers who send us materials that we can upload for students to help them, especially those who are in the remote areas and those who don't have access to these materials. We pray that you continue to have the strength to carry out your work and to help our children in whatever they are studying. Thank you so much in your contribution for building the minds of our young children. All right, question 38. The probability of B prime intersection A equals 3 on 20 and the probability of A intersection B equals 1/4. Find probability of A. So I'll start by considering the vein shown. So this vein, that is B. I want to look for B prime. So this region in black is B prime. Now let's look for B prime intersection A. So I'm going to include A. So this region like this, that is in this funny blue, all of this blue region is B prime intersection A. So how do I get the probability of A? Now that I have probability of B prime intersection A, which is this blue region, I equally need the probability of this other small region like this. This other small region that we have this arc, that's the probability of A intersection B, so that I can have the complete probability of A. So this will be equal to probability of A equals probability of B prime intersection A plus probability of A intersection B, and this will be equal to 3 over 20 plus 1 over 4, and this gives us a value of 3 on 20 plus 1 on 4, which is equal to 8 on 20. 39. Alright, so our key here is 2 on 5. 39. Given that a random sample of 100 is taken from a population with a mean of 80 and standard deviation of 20, the distribution of this sample mean x bar is, this question is repeating, is one of the 2019 questions. So recall that the normal distribution is given by the mean and variance. So from here, our x follows a normal distribution with parameters 80, where 80 is what? Mean. And what's the next one? The variance is 400. So how do we get the standard deviation? We know that the standard deviation is equal to the square root of variance now. Alright, but now they have given us the standard deviation to be 20. So how do we get the variance from this? We square it. 20 times 20 is 400. So our normal distribution is 80, 400. Those are the parameters. Given that x follows this binomial distribution, the standard deviation of x is, this is what we have just discussed in the previous question. So the standard deviation is the square root of the variance, that is the square root of 16 in this case. And the square root of 16 is equal to 4. 41. A random variable x which follows an exponential distribution has a probability density function f of x defined by f of x equals 3 exponential minus 3x. What is the variance? For an exponential distribution, it is denoted by f of x equals lambda exponential minus lambda x, where the parameter is lambda. And for this distribution, the variance is given by the reciprocal of the square of the parameter. So 1 over lambda square is the variance. And from this equation, equating variables, you see that our lambda is equal to 3. So our variance here is equal to 1 over 3 squared, which is 1 over 9. 42. For a certain distribution, the equations of the regression lines of y on x and x on y are that and that, respectively. The product moment correlation coefficient for this distribution is. Here we must note that the line y on x has a gradient of 0.704, and let us call this gradient b1. So here our b1 will be equal to, for the line y on x, r times sy on sx. So this is what you have for equation 1, and you have seen these equations in product moment correlations. And then for the line regression line x on y, let us use b2. So we are going to call this 1.140 as our b2, and this b2 will be equal to r. Note that this correlation does not change whether you use x on y or y on x. But in this case now, since this line is x on y, so we have the s on x on top as numerator on y, equation 2. So from here we are solving for r. So now making xy on sx the subject in equation 2 and substituting in equation 1, it gives us, we will have in equation 1, have our b1 to be equal to r dot. When we make this sy on x here the subject of the formula, we'll have sy on x to be equal to r on b2. So we substitute here, we have equation 3, and we can put in our values and simplify. So r squared, here r squared to be equal to b1 times b2. Normally I could just do this thing directly, but I want you to know that whenever you have something like this, know that your r squared is equal to this b1 and b2, this gradient times this gradient, and then or the square root of the product of those gradients, and this gives us a value of 0.896. 43. Given that x follows a binomial distribution m 0.8 with expectation equals 16, the value of m is, for a binomial it has two parameters n and p, and the expectation is given by np. So here we have our 16 to be equal to np, which is m times 0.8, and m is equal to 16 divided by 0.8, which is equal to 20. So our key here is B. 44. A random variable x is such that it follows a Poisson distributor with parameter 7. What are the modes of x? Whenever a random variable x follows a Poisson with parameter lambda, then there are two things that are involved. One, the modes are lambda and lambda minus 1 if lambda is a positive integer. In this case, we have a positive integer, so we are going to have two modes. However, if it is not a positive integer as we have, the mode is the largest integer, less than or equal to lambda, if lambda is a non-integer. That is, if lambda is not an integer, then we take the nearest integer, which is less than or equal to lambda. So in this case, our modes are 7 and 7 minus 1, that is 6 and 7. So we have C. 45. The mean of a set of 5 values is m, and the mean of the second set of 8 values is 16. Given that the mean of the combined set is 13, of 13 values is 17, what is the value of m? We use the mean of the combined to look for m. So the sum of all the 13 values should be equal to, because we, in this particular case, for the set of 5 values, we divide by 5, that is the sum by 5 to have m. So to have that sum, you say 5 times m. Then for this one, we divided by 8 to have the mean to be 16. So to have the sum of all the 8 values, we say 8 times 16. We sum these two. Now, the mean for all the 13 numbers, they have been told that is 17. So all of this divided by 13 should be equal to 17, and when we solve for m from here, we will have our m to be equal to 18.6. So the mean is 18.6 for those five first values. For the mechanics students, please you can tell them to watch the video titled 765, where they'll have their own corrections. But note that these first 535 questions here are the same for the mechanics students as well. This question says the hypothesis test is designed to test. This is a question that repeats from 2019 also, and they have just changed some values and some few things, but it's the same question. They have altered some values of the result of these values here, alternatives, but the answer is the same. Nothing has changed. So you can go through 2019 and you see this same question. Alright, so for this question, a hypothesis test is designed to test a combined population mean of 420. A random sample of size 100 drawn from the population had a mean of 423. If the population variance is 144, then the statistic for the test is, so the test value is given by z equals x minus mu on sigma on root n. So this gives us 423 minus 420 on 12 divided by root 100. This gives us 2.50, the same answer for 2019. So this is the test statistic or test value. The table below shows rankings of 4 contestants by 2 judges X, Y, and Z. Find the Kendall's coefficient of rank correlation for the above data. Note first of all that Kendall's is different from Spearman. They have been given Spearman all over the years, but this particular year they have given us Kendall's. So for Kendall's, we first of all make a table like this. You can see now we copy out these values like this. I want to display like this, that is easier for me to explain better. And we must make sure that for this first on this table, these numbers are in increasing order. As you can see, in increasing order. If the numbers were not in increasing order, then I will make them to be in increasing order. But note that whenever I change any value, I must take the corresponding entry of ry. For rx, I must change one of ry. So for the first one, it should be in increasing order. In our case, it's already increasing order, so don't change anything. Then we write out our ry like this. And then these c's are for the values of conformance. So here, now we make rx in increasing order. If it's not increasing order, once you order it, then note that ry also vary. The second thing to do is to compute the c values. And the c value is a count of the number of ranks in ry which are higher than the rank in the considered row. So if I consider this row, look at this row, this is where ry is. I count all the values along this column that are higher than this one. So the first value here along this row, how many values are below this row that are higher than 1? We have 1, 2, 3. So I'm going to write 3. This is the next row. Looking at this row, how many ry values are higher than 2? We have 3 and 4, so that 2. And then if the next row, which is 3, how many ry values are higher than 3? It's just one value, which is 4. And then for this row, there is no other value again that is there that is higher, so I'll just put a 0 there. And then the next thing now is to compute the values of d. To compute the value of d, we do the same as we are doing in c, but we now consider by the values that are lower. The same for the same ry. So I'll come now to d. This first one is 1. How many values are lower than 1 along this column? There is no value. Along this column, how many ry values are lower than 2? There is none. Along this column, how many ry values are lower than 3? There is none. And along here, there is none. The next thing to do now is to sum them. You sum the c, the c's, and the d's. So for this column, you have the sum is 6. The sum here is 0. And then now our r Kendall is equal to c plus d minus over c minus d. So we have 6 plus 0 over 6 minus 0, and that gives us 1. We have discussed more about this in our blog on GCE Math Panel Online classes. The blog GCE Math Panel Online classes. or you can go to gcemathspanel.blogspot.com, and from there it will take you directly to the blog. So our key here is C. Question 48. A population has mean mu and standard deviation of 4. A random sample of 64 taken from this population has mean 24. A 98% confidence interval for mu using the sample is. So for the 98% confidence interval, our Z value is 2.326. I know you know they think the values of 95, 97, 98, 99 confidence intervals by heart. You don't even need to use a formula booklet for this, because you have been working with this in class all through, and even the 90%. So the population mean will be given by mu equals the sample mean plus or minus the Z value times sigma on root n. So we put in the values, and this is what we will obtain. We have a sample of 64, we have a standard deviation of 4, and our alpha value is 2.326 at the 98%, and population mean is 24. So when we simplify, we have 22.837, 25.163. Our key here is A. (49) A continuous random variable x has probability density function defined by that. The value of the constant k is. So we know that the probability density function, the integral of that function from negative infinity to positive infinity is equal to 1. But this function is only defined from 1 to k. So we integrate it from 1 to k and equate to 1. When we integrate, we have x minus x squared on 8 from 1 to k is equal to 1. And when we solve for k, we end up with a quadratic equation, and that quadratic has two roots. We have k equals 5 and k equals 3, but they have given us just one of the values here. Here we'll just consider the one that is there. K equals 3 from 1 to 3. If you're not clear with any concepts, you can watch this video over and over again. Don't forget to subscribe, leave your comments, like the video, and share. And the last question, but not the least, to estimate the variance of a population, two independent samples are drawn to produce the following results. So we have for sample 1, we have 40 items with a variance of that. Sample 2, 50 items, the variance of that. What is the unbiased estimate of the population variance? So for all the sum of all the 90 scores we have, for this one, to have the sum of all of these scores squared, we have 40 times this, because it's divided by 40 to have this value. So now plus this one times 52, and we divide all of this by 40 plus 50, 90 now, because it's unbiased, and this gives us 1.488, which you can round up to 1.49 to 1 decimal place, to 2 decimal places, sorry. Thank you guys for staying tuned, and the next paper is paper 2. Don't forget to watch paper 2. Paper 2 will be uploaded, it's already uploaded. Look at paper 2 and as well as paper 3. Leave your comments on the links below, and follow us on Facebook. We have live classes on Facebook every Sundays from September to May, every Sundays. And equally, we have classes, intensive preparatory classes in our blog, where we have tutorials and what we call super quizzes at the end of each month. And all students working with us are compelled to work with this. Thank you so much, and stay tuned. Don't forget to watch the other papers, and we are together. Goodbye.